Aerial compressors are designed for ease of operation and maintenance, as well as durability and long life. This training presentation will focus on the valve, generally considered to be the heart of and perhaps the single most critical component of the reciprocating gas compressor. The valve is simply a spring-loaded check valve that keeps the gas flowing through the cylinder in the right direction. What makes the valve function so critical is the valve is expected to open and close with every piston stroke, up to 1,800 times per minute and in excess of 500 million times per year, and under every imaginable operating condition. This includes being exposed to wide temperature ranges, operating in the presence of dirt and grime, including the sticky and corrosive residues from the gases that are being compressed, and operating with a wide range of gas properties. The valve must also withstand twisting, vibration, shock, and the impact of continuous opening and closing. The typical valve assembly includes the valve, the flat, soft steel valve gasket, the valve retainer, the retainer keeper thumb screw, an O-ring or soft metallic wire gasket, the valve cap, and the valve cap bolts. Each cylinder uses two types of valves, one for intake, suction of gas into the cylinder, and the other for discharge of the gas out of the cylinder. Gas can flow through a valve in only one direction, and the intake and discharge valves are not interchangeable. An easy way to identify the direction of gas flow and whether the valve is suction or discharge is to push against the valve plate with a small screwdriver. The plate will only move in the direction of the gas flow. The aerial design prevents the accidental interchange of the intake and discharge valves in R and larger cylinders. In M, N, P, Q, J, G, and W models, the valves will fit into the wrong pockets, and extreme care must be taken to assure that suction valves only are inserted into suction pockets, and that discharge valves only are inserted in discharge pockets. There are nameplates on the cylinder to assist in identifying the suction and discharge pockets. Before we demonstrate the removal and replacement, a note about safety. Ariel places a high premium on safeguarding the operators, users, and maintenance personnel that work on or come into close proximity with the equipment. Important caution statements are boldly displayed in the operating and technical manuals, as well as on the compressor units. We will highlight these cautions when they relate to the various steps that you'll see in the following demonstration on valve removal and replacement. The first caution alerts the technician that the suction and discharge valves are not interchangeable. Also, tags are used to identify the suction and discharge valves. Larger units may have multiple intake and discharge valves on each cylinder, so that a given compressor could have many valves, each required to function flawlessly in order for the compressor to do its job. While valve design and valve technology are well developed, the demands made on the valve and the harsh operating conditions require proper valve maintenance and occasional valve replacement. Two additional cautions must also be observed before beginning the valve removal process. Severe personal injury and property damage can result if the pressure system is not completely vented before loosening the valve cap bolts. To prevent personal injury, assure that the compressor crankshaft cannot be turned by the driver or by compressor cylinder gas during maintenance. On engine-driven compressors, remove the center coupling or lock the flywheel. On electric motor-driven compressors, detach the driver from the compressor or lock out the driver switchgear during maintenance. To assure optimum performance and reliability, use authentic aerial parts that identically match any parts that are removed or replaced. Use of non-aerial parts can result in decreased performance and reduced life. To begin valve removal, first, loosen all of the bolts on each valve cap a few turns. With all of the bolts loose, the cap should stay in its original position. If it pushes out on its own accord, stop. Take steps to completely vent the cylinder before proceeding. The next step is to remove the valve cap bolts and pull the valve cap. Leave one of the cap bolts engaged 2 threads to prevent it from falling and causing injury to the technician or damage to the part. A pair of pry bars or screwdrivers, one on each side of the cap, will help to pry the valve cap loose. Before proceeding, a note of caution. Personal injury can result if the retainer keeper thumb screw is not firmly in place when a lower valve cap is removed. The discharge valves are typically located on the bottom, and the retainer could fall out when the valve cap is removed if the thumb screw is not tight. Also, discharge valves may be very hot if the unit has just been taken out of operation. Care must be taken to avoid bare skin contact with the hot valve. Once the valve cap is safely removed, screw a valve tool over the valve center bolt, and the valve and retainer can be pulled out together. Often, the flat metal valve gasket will remain in the pocket. It's difficult to see, and Ariel recommends using a flashlight and small mirror on an adjustable rod to see the gasket clearly. On cylinders with horizontal valves, the gasket may fall into the gas passage, and a small magnet on a flexible extension rod will help fish it out. This gasket should be discarded and replaced with a new gasket each time a valve is removed. Before reassembly with a new or reconditioned valve, be certain that all parts, gasket faces, and mating surfaces are absolutely clean. To begin reassembly, the soft metallic flat gasket should be coated with an anti-seize lubricant. It can then be inserted into the valve pocket or stuck onto the valve. In either case, care must be taken to keep this gasket from falling into the gas passage. Caution! Severe personal injury and property damage may result if the suction and discharge valves are reversed or not installed in their proper location. Using the valve tool, the valve and the retainer may be inserted into the pocket together. Then rotate the valve and the valve retainer one turn in the pocket to be certain that both are seated properly. The retainer keeper is a plastic thumb screw that is threaded into a hole in the valve retainer. This should be screwed in just far enough to provide friction so the bottom retainers will not fall out when the cap is being installed. When correctly installed, the distance from the outer retainer face to the surface of the valve boss on the cylinder will be 1/8 inches, or 3 millimeters shorter than the length of the nose on the valve cap. Inspect the valve cap O-ring for cuts or gashes and replace if necessary. Lubricate the O-ring and the nose of the valve cap with clean oil and insert the cap back into the unit. The next 2 steps are very important for proper completion of the task. First, lubricate the threads and bolt seating surfaces with petroleum-type lubricant and install the bolts. Do not use anti-seize compounds on the valve cap bolting. Finally, to assure proper sealing of the valve caps, the following fastener tightening technique is essential. It's important to draw up the bolting to full torque in even and gradual steps. Do not allow the valve cap to be tightened with bias on one bolt and with the valve cap cocked in the bore. This bias or cocking can cause damage to O-rings or gaskets and can lead to leaking, bolt failure, and valve failure. Tighten each bolt in gradual steps until snug using an ABC, BCA, CAB pattern for 3-bolt configurations and a crisscross pattern for 4-bolt and 5-bolt configurations. This should be easily accomplished by hand tools, and if not, the bolts should be backed out and inspected for thread damage. Do not use an impact air wrench for installation of any bolt in an aerial compressor. Next, tighten each bolt to 25% of full torque, moving across from bolt to bolt, again using the ABC, BCA, CAB pattern for 3-bolt configurations, and the crisscross pattern for 4-bolt and 5-bolt configurations. Then repeat this step for 50%, 75%, and 100% of full torque. If the assembly is correct, the distance from the underside of the cap to the valve boss surface on the cylinder will be a uniform 1/8 inches or 3 millimeters. Valve replacement is now complete, and the compressor unit is ready to return to service. But before proceeding, a final caution. Before starting the compressor, be sure to complete and check off all items on the startup checklist in the Aerial Technical Manual and the packager's operating manual. 2 very important startup items will be to purge the system of air and to leak test the valve caps. To purge the system of air, gas is introduced into the compressor by opening the suction block valve, and air is forced out of the system through the open blowdown valve. When gas is evident at the outlet of the blowdown valve, the system is purged and the blowdown valve should be closed. Leak testing is accomplished with the use of a soapy liquid applied around the valve cap and bolts. When gas is introduced into the cylinder, no leakage should be evident around the valve caps. If leakage is found, the problem is probably a faulty valve cap O-ring, which must be replaced. The problem cannot be corrected by simply tightening the valve cap bolts. Before removing the valve cap, the compressor must again be completely vented before loosening any bolts. After replacing the valve cap O-ring and torquing the valve cap bolts, the compressor must be purged of air again by opening the suction block valve and forcing the air out of the system through the open blowdown valve. When gas is evident at the outlet of the blowdown valve, the system is again purged. Now the leak testing procedure is repeated. If there are no leaks, valve replacement is complete and the unit is ready for service.